Alright, so this is next lesson, which is 14. The next type of reaction is a single replacement reaction. And what actually happens is you start out with an element by itself and a compound, and that free element kicks out the first element in the compound, takes its place, and that's a single replacement reaction. It always involves one element and the compound on both sides, and it only occurs if the element that is free is more active than the element that's the first element in the compound. And I'll give you here's a video demo that you can watch. Okay, so that's an example of a single replacement reaction, which is here. Potassium is a metal. It's an alkali metal, group 1. It's extremely reactive, as you can see from the video. As soon as you dropped it in the water, now notice how they wrote water a little bit differently than normal, but it can also be written that way. It reacted immediately, gave off hydrogen gas, and formed potassium hydroxide. You could tell it was a chemical reaction because you saw the flame. Obviously, there was heat and light being given off, obviously a chemical reaction. That's the general format. Here's an example of another one. You start out with an element, react it with a compound, and you form another compound and an element. So let's quickly run through exactly what's going on here. If you look at the reaction, here's the element by itself, here's the compound, here's a compound and the element. What happens is, if you look at magnesium as an active metal, so this reaction is only going to occur if magnesium is more active than the first element in the compound. And in this case it is. How do you know that? Well, there are reference tables. Table J will tell you that, and we'll get into that. So what ends up happening is, because magnesium is more active than hydrogen, it kicks the hydrogen out and replaces it and forms magnesium chloride. And you should understand why it's MgCl2 and not MgCl, because remember, magnesium is a -1, and you have two of them, that's -2, and magnesium is a +2. And hydrogen is Brinkelhoff, so when it's by itself, it has to be diatomic. So that's an example of a single replacement reaction. Now, the reference table that you're going to use. Alright, so let's get into it a little bit more. In order to determine if that first element is more active than the element that's written first in the compound, you're going to need to use one of your reference tables, and you're going to need to use reference table J. So again, how do you determine if that reaction is actually going to occur? The element that's by itself, in the previous example, it was magnesium. So let's, and you're obviously going to need to take out reference table J. You can't just follow along without looking. The reaction that we had was, we take a piece of magnesium and we put it in HCl. And is it going to react? Well, if this first element is more active than this element, the reaction is going to occur. And how do you know that? Well, it has to be on table J, it has to be above table J. So if the first element is above H on table J, the reaction will occur. If the first element is below, for example, H, it will not occur. And it's not always going to be H, so you just compare this element and this element. If the free element is above this element on table J, the reaction will occur. If it's not, then there would be no reaction. And you have to be able to figure that out. Here's an example. If you look at this equation, you have to look up lithium and see if it is more active than sodium. So you'd have to look on table J. So here's table J. So let's take a look. So let's see lithium. Now, all we did was write it backwards, right? It's the same thing as writing this. It's no big deal. So let's take a look at lithium, see if it's more active. Oh, definitely is. It's at the top of the list. It's more active than sodium. So this reaction will occur. What will happen? The lithium will kick the sodium out, and it will form this compound, and the Na will simply be by itself. Now, take a look at this one here. This is a little different. You have chlorine, but chlorine's a nonmetal. So now you have to compare this to this. Problem is that chlorine is not as active as fluorine, so this reaction will not occur. And let's take a look at this. Is magnesium more active than sodium? Well, here's sodium, and magnesium is not more active, so this will not occur. And that's how you use table J. Alright, so let's do a couple of equations. This is not synthesis reactions. These are single replacement reactions. So let's just do the first one. And again, I'm not going to go through and do a lot of these. So we have, let's see, we have 1K and 2 Cl's and 1 bromine. On this side we have a K, a Cl, 2 bromines. Well, let's see. So the chlorines and the bromines are not balanced. Doesn't matter where we start. Let's do the chlorines. If we put a 2 here, that'll now give me 2 chlorines, but it also now gives me 2 Ks. So I simply have to put a 2 here. That gives me 2 Ks. It also now gives me 2 bromines, which I needed to begin with. So it's now a balanced equation. Now let's take a look at this one. Notice it's a little different now. You notice that you have a ternary compound. We haven't seen that before, and here's a little bit of a trick. Instead of balancing the C and the H and the O, do the polyatomic ion as one unit. Balance these instead of doing each element separately. You see that I have 3 acetates, that's what this is on this side, but I only have 1 here. So I have to put a 3 here. That balances it out. It means I got to put a 3 here. And that would balance it for me. Now look at number 3. Notice I wrote, instead of water, I wrote HOH, and sometimes it's easier to do that. I have 2 H's here, but I only have 1 here, so I got to put a 2 here. That would mean that I have to put a 2 here also. That would give me 2 OH's, but it gives me 2 lithiums. Put a 2 here, and I'm done. And again, of course, you could do what we did before and do these word equations. So let's take a look. So it says, use table J to see if the following reactions can occur. If it can, write the product and balance equation. Remember to do the crisscross method. So what you have to do is, in each case, you have to look up the first element, compare it to this element. If zinc in this case is higher on table table J than H, the reaction will occur, and you have to figure out what the products would be. Same thing here. Look up Pb and Fe. If Pb is higher on table J than Fe, the reaction will occur. The Pb will then replace this. In this one, you got to be careful because now you're not looking at the lithium, you're looking at the iodine because that's a nonmetal. So if chlorine is higher than iodine, this reaction will occur. And I'm not going to really spend the time doing that in this section because it would just take way too long for the video.